It's smoking now.
The two most popular hot ends are the Mark 8 and V6, popularised by Creality and Prusa. Both have their strengths, such as being cheap, accessible and easily usable, but they're both air-cooled and have a relatively low flow rate, not to mention the stock nozzles. Printing abrasive materials on a stock nozzle is not possible unless you want to wear it down quicker than my latest speed Benchy, which is 8 minutes 43 on my Ender 5 using the Dragon Ace hot end. So the plan is to make a hot end that's the opposite of all of that and worthy of going on my slightly modified Ender 3. Let's get to designing. Before I start, I have some design requirements. That being, I want the hot end to have high flow, excellent temperature ranges, easy mounting to my Ender 3, and be water cooled just for fun. It has other benefits too, but being water cooled is good enough for me. A bimetal heat break is a must, and finally easily replaceable components for servicing. While I can't draw, I had a friend sketch me a concept which helps me get a better idea of the project. I asked this to be drawn way before I knew what I wanted, but you'll shortly see it actually holds up. In terms of compatibility, I think I'll go with the Ender 3 hot end mount as it requires the least amount of changes to the machine. The V6 groove mount is still great, so maybe I'll try it next time. For the heat break, I decided on the Mellow Crazy heat break for the Ender 3. Since it has no thread for the heatsink, I could easily switch it between the heater blocks if required. I also only ordered one, so it kind of is required. In the likelihood that the water cooling fails, I can also use air cooling instead. Choosing the water cooling parts are also simple enough. By going DIY, it's actually cheaper than the off-the-shelf alternatives, but there's more to it than that. Finally, we have the most important part, the heaters. I'm very familiar with cartridge-style heaters, but on my Ender 3 and Ender 5's current setups, flat ceramic ones are used, so I'd like to try them out. I settled on two different models, both 24 volts, but one set is 20mm at 48 watts each, for a total of 96, which is roughly double the average hot end wattage. And the others are 70mm with a wattage of 115 each, for a grand total of 230 watts. Around double the wattage of the CHC Pro from Triangle Lab, but in a much larger space. My AliExpress cart is filled with tons of other heaters that I'd love to experiment with in the future. By the way, one other common feature that both the V6 and Mark 8 hot ends have is that their heater blocks are made of aluminium, since that's readily available and cheap. However, copper offers better thermal conductivity and higher maximum temperatures. We'll also be nickel plating it for even better durability. I won't be doing any plating, but PCBWay will, since they're the ones who'll be machining the blocks, but we'll get to that. First, we need to actually design the parts. Sometimes, before jumping straight into CAD, it's good to write your ideas down on a piece of paper, but getting them off the page and digitalized has been the main factor stopping me until now. This is the BenQ Idea Cam, and it's easily the most versatile webcam I've ever used, with easy top-down shots and measurement tools, macro features that rival professional camera gear.
Whoa, wait, that's better than my macro filter.
And some powerful software to boot. It's actually a really insane little tool. While I didn't expect it to work well with my setup, I can install it on my TV for some pretty entertaining angles. And it overall is a great device. There's a link in the description with more details, and thank you to BenQ for letting me try this out. Alright, this is it. I'm not sure what one this is, but I'm just going for it. I'm a little nervous, but here we go. Wow. I don't know if I can express how small this is. I mean, it's obviously tiny, but it's beautiful. Alright, here's the next one. Wow. That's the heatsink. Copper is absolutely beautiful. It's even better in person. It's strong too, I forget it's actual proper metal. So there's a little M2.5 tap in there. It's incredibly well done, and it's heavy too. In case it wasn't obvious, PCBWay is supporting this video. My first experiences with their CNC machining services have been more than excellent, and the SLM, SLS and SLA parts I've previously requested have all been amazing. They have so many services to bring your project to reality, so check them out and see what you think. I'm trying their laser cutting for my next project, and I'm pleased to say the parts turned out flawless. As always, there's a link to their site in the description, and thank you PCBWay for providing the parts and your support.
The heatsink does fit, but it's not perfectly aligned. That's just a little cosmetic issue, it won't affect anything.
Okay, this thing's cool. It's got a CHT splitter in the middle. I'm going to zoom in so you can see that. Super cool. Hardened steel as well. Bit of everything. Luckily this is pretty simple. We just screw the nozzle in until we get it looking like this. And now we take our bimetal heat break, and there. That can't go in any further. If you haven't picked up one of these nozzle tools, they're like $2 on AliExpress. One of the best things I've ever bought. I absolutely love the nickel plating on the block, the copper color of the heat break, and the darkness of the hardened steel. It looks amazing. You may notice that the piece slides all the way in. Well, screws all the way in. Unfortunately, there's still like a millimeter or two of room. I measured it. So I had to make a spacer. I had it a minute ago. I can't seem to find it now. Can we cut to where I find it, please? Thank you, past me. I'd like to announce that it was exactly where I left it in the storage thing. It was literally like that and I couldn't see it. Splendid. But as you can see, it is absolutely tiny, and there's a little thread at the end, and then here, oh, so this will go into the heater block and give us just enough space to screw the nozzle in perfectly. And the tool barely reaches as well. Okay, that's it. That's as far as it can go, and it's literally flush. I'd rather have it a bit further out than in. Pretty good. The melt zone is crazy big on this. Installing the heat break is the same situation. It looks absolutely amazing, but let me grab a Hotend for comparison. Aligning the heater blocks makes it look like this. And if I do this, large Hotend is actually longer than the V6 and the Mark A. Since I need a vise to tap the threads on this part, I'm going to go do this in the workshop, so I'll see you guys in a few minutes. So of course I wasn't recording for this, but I broke a tap inside of the part. So I'm going to try and get it out, but I don't know what to do now, and I broke a drill bit as well, trying to get it out. I'm just going to leave it for a little bit. What's really awesome is that the TZ2.0 Hotend for the Ender 3 actually has connectors, so I don't have to go and trace back everything, which is great. Very nice. And for those who don't know it, this is the Artemis extruder. It is my favorite extruder. I've had the best print quality ever with it, and it's 105 grams, even lighter than the Orbiter V2. But unfortunately, even the small Hotend draws almost 100 watts of power, and the big one draws 230? So we're gonna need a relay. Here's the relay, and here's the mount for the extruder and for the other parts. I'm printing these in carbon fiber PETG, and it's looking pretty decent. I finally get to retire this heatsink cooling fan. It's been through quite a bit. Wiring has got to be my least favorite part. There we go. That's what we're looking for. So these three are the negative, these three are the positive. I'm gonna wire this in here. This really isn't a how-to, this is just me messing around. So try not to copy what I do. It's really less than advisable. My design was definitely inspired by the TZ2.0 Ender 3 Hotend. I just wish I found these clips. I found these ones, but not larger ones, custom ones for my design. So one of the biggest flaws is that I don't have an easy way to mount the ceramic heaters. I'm going to have to use tape. All I know for certain is that for V2, I want better thermistor and heater cartridge mounting. I want to be able to add a silicone sock, and I want the design to be better. I just want to remove this Kapton tape. I'll apply it again later. They look really nice. Alright, so this is going to be a little bit problematic since it's not a perfect dimension, but we're going to use tape and it should be fine. Okay, that's the first layer done, so it's holding the blocks in place. It is nice and dense, but we'll have to see how it holds. Actually, I'm going to remove the thermistor from this Hotend because it's already got the connector, so that saves me some additional wiring. So you can see the thermistor there. I think I might tape it and then add the grub screw. I should have had it vertical, but I didn't know how to design this part for subtractive manufacturing. I'll just have to get better over time. Since I don't have a silicone sock, I just have to tape up the whole thing, which is not as good as a silicone sock. It doesn't look as cool either, but... And now we just need a grub screw. Okay, I'm back, and I made a little change. I tapped an M4 thread and put an M4 grub screw in there. M3 was not working. The cable grooves do work though. They're the right size, which is nice. I guess the only real test is printing, but this thing is... It's solid, like it's all rigid, it's not moving, it's really good. Okay, so now I need to actually install the fittings for this thing, which luckily isn't too hard, but it's a tight fit, so that's something I'd improve for part 2, but this thing is looking really close to being done now. Alright, time to install on the machine, but I forgot that I can't install it with the fittings on, so I'm going to take them off real quick. And then tighten that up. That is rigid. Oh, that looks amazing. I'll be very surprised if this doesn't leak. I seem to be using a lot of brain power today because I also forgot to install this bracket, so I've got to redo everything again. I forgot about that transition. Never mind. Oh, well that was a lot easier than expected. I'm always a fan of that. Now theoretically the unmatched extruder will be able to easily mount to that. Oh, we might need a PDFE tube. Here, I'll go grab that. I wish I could use the unmatched extruder on the Ender 5 as well, but the Orbiter V2 is on there instead. Maybe in the future I'll get a second one. Near perfect spacing. Nice. Now we install the pump reservoir. There we go, that'll hold. This is a 24 to 12 volt step down converter, which we'll use for the reservoir and pump. And there we go, one wire powering both things. Very clean. Workbench is still very messy. This is going to take up a little bit more space than I expected, but as long as it performs well, I don't mind. I don't print anything too high. I printed these little adapters and they essentially turn a PTFE tube into one of the actual tubes. And then it simply mounts on the end like this. Alright, I'm going to do a dry run, so if anything bad happens, we're about to find out. Pump is going, nothing's blown up. Okay, adding the fluid now. I won't be using anything fancy, just some regular demineralized water. That way, on the high chance that I end up spilling it everywhere or there's a leak, which is an even higher chance, it won't short anything. Oh no, it's leaking. Where's it leaking from? Oh, I know where that is. Okay, so I was expecting this, but yeah, the fittings, they are leaking a little bit and the grub screw on the side, but that's because the thing is a little bit loose. I'm gonna try add some more tape to that. The rest of it seems to be okay. Okay, I was expecting it to be worse, but I'm sure there's some I told you so moments in here, but I can get this working. The good thing is it's actually cleaned the carbon fiber. Take 2, and add a little bit more this. Never mind. This is my last attempt. I can't allocate any more time to getting the water cooling working. I've added so much to this part. Okay, I'm just gonna power it on. I'm just gonna go for it now. Well, it's leaking from there. I should have just stayed with the larger tubes instead of going to the PDFE fittings. I think that was the flaw I made. I'm not leaving until we flow test that small block and the big block though, even if I have to use air-cooled to do it. I feel like I'm going in full circle. Well, as long as it prints fast and good, this video will be a success. My poor Ender 3 has been through so much. It's only got one video left after this one. I'm not really a fan of unpredictable projects, but they're usually more interesting and educational as well. So, I don't know. Alright, I installed the bracket and the PDFE tube. It's a little bit tight, but we've got the Ender 3 heatsink on the custom Hotend block, which is good. Sweet, super simple, love that. This absolute mess that I need to clean up. I think we're all done though. Alright, so when I flip this power switch, the fan should start spinning. Brilliant, okay. What about the screen? The screen turns on, okay. Even more good news, we have accurate temperature reading. If I put this up to 40, this should start heating up. It looks like one of those old, like rep Hotends or whatever from back in the day. Oh yeah, the power consumption. I mean, it's 96 watts of power going to, yeah, it's hot. Question is, how well will the tape stand up to? The tape is supposed to go to about 240. The PID tune is looking good though. So no irregularities or anomalies, which is really good. This is my favorite filament, the Jamhe high-speed PLA Plus, and that's what we're gonna be using. Oh yeah, the Z offset. I think I got it correct. I forgot how fast this printer is. I'm gonna let the machine handle it now. Speed, maximum, distance, maximum, extrude. Something's wrong. I think the main reason is not that this part was broken, but the fact that I uninstalled this piece here and kept using the long screws. Fully assembled. That's how you service the unmatched extruder. Extruding in 3, 2, 1. Oh, I fixed it. I knew it. I knew it was the problem. The unmatched is really satisfying to watch as well. Look, it's going at full speed now. Alright, this is a Voron Cube test print. It's doing it.
We're extruding, we're printing. We're printing! Yes! This is amazing! Okay, I'm gonna cut. Hey, do you see how fast it's going? Can you hear that?
Oh, it's probably not loud enough. I have no part cooling though, but I am so excited to get the part cooling installed. Here, I'll give you spoilers, why not? I'm not going to install them today. Here, these are the fans. Here, can I get them in frame? These, two of them, 2 server fans are going on this machine. Check out the community posts. I cancelled the print because I forgot to hot tighten, so we had a couple issues there. But then, all of a sudden, it just glowed orange. You can see the wire there. That wire is meant to be attached, so it just glowed orange and melted off. I guess the wires got too hot, too much current going through, which is a bit weird because this is how they were from the factory. It should be able to handle it. So I'm just going to replace it with the larger heaters, with the larger hot end. Alright, I've installed the connector now. I'm not sure if it can handle the current, but it is the connector that was used for the hot end, previous hot end. That looks crazy. Alright, this is it fully tensioned. Let's just get it installed. This looks so incredibly stupid. It's like a super volcano hot end, but much slimmer. And what, double the power, at least? Very experimental. This isn't something I would daily drive. Okay, so I've decided I'm not going to use this connector here. I do trust this side, but I don't trust this side. I'm just going to wire the heaters directly to the cable. I don't want to take any risks. Okay, I just felt it. It was already starting to heat up. That's not good. See, it's already started heating up. Why? I don't know. Well, I'm just going to disconnect the back wire. Okay, that's just residual heat. 70 degrees? What? So it's just decided to dump a whole load of current into it. I don't know why. Right, so you can see how the temperature is 102. If I touch this wire here, you can see it starts going up. So it just goes. It's maybe the relay's broken. I don't know. I'm gonna steal one from the Ender 5 since that's the only machine with a DC to DC relay. But if that doesn't work, I got nothing left. What I don't get is that it's the exact same relay, same brand, same everything. Okay, I've wired it up correctly. Should be fine. I was gonna use this, but that's a DC to AC relay. It doesn't feel like it's warming up. Okay, I'm hoping it was a dud. I'm really hoping it was a dud. 51 degrees, going down. All right, so I would do a, what was I gonna say? This is the first ever attempt to extrude filament. It's taking a lot of filament to... Extrusion! We have extrusion. Can it go fast? Yes, it can. Okay, I'm just gonna do a little home sequence and it should be all good. And then we can get to printing. This will be interesting. I'm printing a Voron cube with a layer height of 0.36 millimeters, and most of the flow should be at 50 cubic millimeters with a 0.6 millimeter nozzle. Let's see how this goes. And you can see our relay is functioning properly as well. It's turning on and off to keep the temperature correct. Okay, I fixed it. We're actually printing. I was so distracted I didn't realize that's actually a pretty big deal. All right, we should be able to keep it on the flow rate as well. Okay, that's a layer shift, so I'm gonna have to cancel this and do a dedicated flow test. Because I was having an issue with the max flow rate test for Orca Slicer, I'm just gonna take a cube, scale it up, 100% infill, and increase the speed, which will increase the flow rate. Yeah, you can see it's leaking a bunch of filament. I've tried hot tightening it, but the heat break is gonna make full contact soon, so I can't do much more. Yep, and they are up to date. This one also says 24. You can hear the sound difference. 48, 50! That's 50! These layers have no cooling, by the way. They're just completely hot. They're completely squishy. Okay, it's doing 50 just fine. 65. I didn't even see the filament. Look how quickly it's going. Interesting, I'm gonna let it do this and then I'm gonna crank it up even more and see if it gets any more noticeable. I'm gonna try 210 Celsius. I really don't want to push it any hotter though, but I'm gonna try 215. Because the point of these long heaters is to have a really long melt zone that's evenly heated. It's mesmerizing to watch. That's a fast shutter speed. I'm gonna bring that down to a slow one. It looks insane. So it seems to be able to do roughly 60, but I need to figure out, I think it's leaking. I think that's why it's not, give me a minute. Oh, this thing is like printing with TPU. They're not too bad. There, see, look, that's really good. So despite a hot tighten, it's still leaking a little bit. And up there it's a mess as well. It's not good. As you can see though, the nozzle is still leaking a bit of plastic.
and it's moving so fast. 74, 74.8, 73, 72, 75. Okay, it's in the 70s and it's doing fine. 70 cubic, and it's fine, it looks fine. Can I push it even more? Can my Y-axis handle it? So the only thing I can do now is increase the layer height, but look, the layers are pretty good. I'm gonna increase the layer height to something crazy. Flow rate testing always ends up with my workbench looking like this. I'm not complaining because it's somewhat fun. Okay, I've increased the layer height to 0.44 and the line width to 0.72, which is insane. Okay, here's how long it's gonna take to go from 20 degrees to 215. Okay, not bad. I'm gonna put on screen the times of some other performance hot ends and we can compare. 75, right off the bat, 75, 83, 98, 98, 100? Okay, can't keep up, sure, but okay, I'm gonna turn this down. Oh, stuff it, I'm gonna increase the temperature to 220. Can 5 degrees really make that much of a difference? We're about to find out. I think it could do it, but it's just leaking. And the Artemis extruder is handling this great. Well, this tape on AliExpress says it can do like 280, so 230 it is. This might be what it needs to handle this crazy... We're already at the same height as before. Yeah, right around the 85 mark, it just lost a bit. Then 96 again. Another block of filament. I'm not sure how easy it is to see the layer lines. There we go. It's hot and it's so funny because there's no cooling. There's no heated bed either. This is costing us a little bit of performance. I know it. I need to figure out a way to fix that. Alright. This is attempt number 5 or something. We're at 230 Celsius. Okay, we have a problem. The Hot Titan was a success. Problem is now, I'm worried the filament is going to start coming up the top of the hot end, which is a little bit of an issue. That's 90, 91. It's holding it. I think that's a wrap. Okay, that was like 4 or 5 seconds of continuous 90, and it was doing fine. Yeah, that's such a win. 90 cubic millimeters per second. This absolute sandwich of layers. It's super hot. It's just a big block of filament. It's so funny. Here. That lighting makes it look a little bit worse, but it looks so good. You can see the blob on the side there. That's really annoying, but nothing I can really do. So this seems to be, well, I can't call it under extrusion because that's not possible. And then because of the lack of cooling, the layers are just melting on each other. So I'm not really sure what to print because I don't have any cooling. That has got to be one of the best calibration cubes I have ever printed. It's not even TPU, it's PLA. Alright. Time to print it at 5% speed. Well, the Benchy has good extrusion lines. Yeah, look at that. That's really good. But the cooling... Well, I can't keep yapping about it. I need to do something about it, but I can't because that is for the next video. Alright, I know we're nearing the end, but I'm going to give one last thing a go. I don't like how it's leaking filament at the top, but I do have a spare heat break. It is a non-all metal. So it will be PTFE lined, but look, I haven't gone over 240, so I have no need. I'm just going to replace it and give it a go. What an absolute mess. So hopefully it improves after this. Okay, I think I've hand tightened that enough for it to work. I really love the way this thing looks, but the Kapton tape really ruins it. If anyone has any ideas of alternatives that I could use, please let me know, because I want to keep using this. I mean, it's so good, and I might have solved the issue. So, well, I think that was a success, so I'm going to turn the power on. Nothing's exploded just yet. Okay, I think we're all good. And there we go. Back to it. Alright, so now that the bottom is sealed and the top is sealed, hot tightened as well, we should have more precise extrusion. The ley lines are looking pretty good actually. Bit hard to see, but they are. So once again, the benchies do exhibit the nice clean layer lines, in some of the areas at least, that I'm familiar with, but I don't want to keep going without any part cooling. I'm assuming the layers are stacking up, getting heavy and squishing. I just don't want to continue because I feel like it's diminishing returns. So we're going to leave it there because I know in the next episode we're going to be improving every other aspect since we've now conquered the hot end. So slight change of plans. I actually forgot something and have to do another test. I forgot to install the hot end retainer clip. You can see it in there. I've done it now. It wasn't there before. Look at that. Now we're actually getting like detail on the first layer. Before it was having trouble extruding. I mean, it was having trouble extruding a bunch, but yeah, now we've actually got some stuff there. Let's see how this goes. Did you hear that? I'm going to boost that so you can hear it, but the moisture. And somehow in the span of one day, this filament has just loaded in a bunch of moisture, so I'm going to have to dry it again now. Sweet, that's printing well, and then we've got something exciting over there. These are all the prints I've done with the hot ends. These Voron cubes were printed with the small hot end until it burnt up, and they look really nice. Aside from the print not completing, the layer lines are very good on this one. The first few objects were spent dialing in the temperatures, retractions and other settings like that. Then we got a completed benchy which looked alright. Some of the layer lines were really nice. And then we had another one which sort of melted. I tried printing it in the iBoss PLA, but it just didn't seem to work out right. For some reason, some parts of the print looked great and then others looked really bad. We of course have our filament block collection, which has some pretty good layer lines in some of the parts. While I did get the performance I wanted out of this hot end, the mounting systems I came up with were really subpar, and there was a lot of performance left on the table. So what did I learn from this project? A lot. First off, water cooling is only really necessary for enclosed high-temp printers. On an open frame machine like my Ender 3, the benefits just don't seem to justify the effort. I did save money by building the system myself, but it ended up being more complex and messy than I expected, mainly due to user error. If I were to do it again, I'd spend more time getting it right with better fittings and mounting, but honestly, I'm just going to wait till it's really needed. Maybe on a full custom printer build. One thing I definitely recommend is not overcomplicating your component choices, unless you're really confident in them. I love ceramic heaters, but it's so much easier to design for cartridge style ones. High wattage can also be helpful for faster printing and hotter temps, but it's not always a must. In my case, the high wattage setup didn't work as well as it could have because of some design flaws. Mainly poor heater and thermistor mounting, and not doing a proper hot tighten on the heat break side, but once again, user error. These mistakes definitely held back the performance and flow rate. If I was to make an improved version, I'd focus more on mounting, like adding proper screws for rigidity, similar to the Mark 8, and I'd also look into integrating a CHT splitter to boost flow rates internally. And I'd make sure everything fits and works together more smoothly. Overall, this project taught me the importance of solid mounting, keeping things simple, and making sure all components work well together. Oh, and to not use tape to mount things, and sometimes water cooling isn't necessary. Sometimes. I've got to get this video out, so thank you so much for watching, and hopefully I'll see you again soon.